Shiv Kumar D, and my registration number is 22BC 5030. And today I have choose to talk about the topic applications of finite automata and search engines. So through this presentation, I will be covering the topics. So first one, the table of contents are: first one is theory of automata, second one is types of automata, third one is finite automata, fourth one is types of finite automata, fifth one is about search engines, and the sixth one is finite automata in search engines. So now coming to the point, what is theory of automata? Theory of automata is a theoretical branch of computer science and mathematics. It is a study of abstract machines and the computation problem that can be solved using these machines. The abstract machine is called the automata, and automation is a abstract, self-propelled computing device which follows a predetermined sequence of operations automatically. So basically, there are four types of automata, but the first one are compared combination logic. Then there are finite state machines. Then there are push and automata, and then there are Turing machines. As we go above, the complexity of automata increases. So, what are the type of automata? There are four different types of automata. Basically, the finite state machines, push down automata, the linear bounded automata, and then the Turing machine. So, what are finite automata? Finite automata are the most basic machine that we can spot around. It has a finite number of states and a set of guidelines or changing between them. That sense, it is a model of digital computer that is abstract. The main order maiden that is described represents which states which are, as we have discussed earlier in the previous slide, types of automata. There are four types: finite state machines, push-down automata, linear bounded automata, and Turing machines. So finite automata is the most basic machine that we can spot around. It has finite number of states and a set of guidelines of changing between them. The sense is a model of digital computer that is abstract. The main order that is described in the image represents state which are represented by circles, and the transition that are represented by arrows. And the automata sees a symbol of input and make a transition or a jump to another state according to its transition function, which takes to previous state and the current input symbol as its argument. So when are the types of automata? What what are these types of automata? There are two types of finite automata: the deterministic finite automata, and there is non-deterministic finite automata. So it has DFA consists of five tuples that are represented by symbols q, sigma, small q, f, delta. So here are set of states. Non-deterministic finite automata or NFA are similar to DFAs, except the following additional feature: the null symbol move is allowed, that it can move forward without reading the symbol, ability to transmit to any number of states for a particular input. It also has transition function which are represented by the by given equation. Some important point about DFA and in phasor: every DFA is an NFA, but an NFA is not always a DFA. There can be multiple finite state in both NFA and DFAs. DFA are used in lexical analysis and compilers. In a phase are more of authorical concepts. So what are the applications of finite automata? As I said earlier in the previous slide, this is finite automata. Yeah. Finite automata is the most basic machine that can be spot pattern. It has finite number of states and a set of guidelines for changing between them. It is a model of digital computer that is abstract. The automata described in this image consists of states represented by circles and transitions represented by arrows. As the automata sees a symbol of input, it makes transition to another state according to its transition function, which takes the previous state and current input symbol as its arguments. As I said earlier in the slide before this, like key ideas in market opportunities. Okay, this is generally deterministic finite automata. DFA consists of 5 tuples. It is generally declared by 5 tuples: Q, sigma, small q, F, and delta. Q is Q can be stated as finite set of states. Sigma can be stated as finite set of input symbols. Q naught initial state. F is a final state. Delta is a transition function. Transition function can be defined as U cross sigma and arrow marks U raised to 5. And here we can say about non-deterministic finite automata NFA. Yeah, like deterministic finite automata, we can say it as DFA, and non-deterministic finite automata, we can abbreviate it as NFA. NFA is similar to DFA, except follow additional features. Null move is allowed, that is, it can move forward without needing symbol ability to transmit to any number of states for a particular input. Some important points about DFA and NFA. Like we can say every DFA is NFA, but we can't say that every NFA is DFA. There can be multiple final states in both NFA and DFA. DFA is used in lexical analysis in compilers. NFA is more of a theoretical concept. And in vending machines, for designing and implementing control logic of vending machines. Now coming to the main topic about search engines. A software program used to do web searches is known as search engines. They conduct systematic searches of the World Wide Web for specific data that is defined in a text-based web search query. Search engines also retain real-time information by running an algorithm on a web crawler, unlike web directories and social bookmarking sites, which are edited by human beings. Some examples of search engines are Google, Microsoft Bing, and yeah, Brave, Yahoo, and etc. Now coming to the topic, search engines work through three primary functions. The first one is crawling, second one is indexing, and third one is ranking. For crawling, score the internet for looking over the code content for each URL they find. Indexing, store and organize the content found during the crawling process. Once a page is in index, it is in the running to be displayed as a result to relevant queries. And the last one is ranking, provided the pieces of content that will be best answer a searcher's query, which meant that results are ordered by most relevant to least relevant. Now applications of finite automata in search engines. String searching, DFA based algorithm. Finite automata algorithm for pattern searching. Finite automata can be used to create a finite state machine that represents a search query. As text is processed, the finite automata can efficiently determine in the search query appears within the document. Now coming to string searching. The string matching algorithm uses a string matching automation, which is highly helpful tool. Every character in the text is examined exactly once in order of n times. It reports all the valid shifts, finding a specific text pattern or placement within a bigger body of text. as we discussed earlier as string searching, now about pattern searching. An important issue in computer science is pattern searching. Pattern searching methods are used to display the search result when we perform a string, each in database, browser, or a notepad word file. We pre-process the pattern and create a 2D array that represents a finite automata in the FA-based approach. The hardest aspect of this algorithm is to create the finite automata. Once the finite automata is constructed, searching it straightforward. Simply said, we must begin our search with the first character of the first text and the initial state of automation. At each step, we take into account the following characters of text, search for the following state in the created finite automata. Change states, the pattern can be found in the text if we get to the ultimate state. The search process temporary complexity is in the order of n. Now coming to the conclusion part. Through this presentation, I would like to conclude that in this new age of technology being used in our day-to-day lives, search engine plays a very crucial part in our life. Finite automata make it possible for the search to function under its immense applications. That's all, and thank you everyone. This is my end of presentation.